I'm Mitch Gallagher. Welcome to the Sweetwater Minute. We have a special guest with us today. This is Dennis Alichwer, Engineering Manager for Rupert Neve Designs.
Well,
that's a pretty impressive title because Rupert's sort of an engineer himself, isn't he?
it is. It's a challenge to work with him, but it's a lot to learn from Rupert, and we kind of carry that through in engineering.
With R&D, you guys take a little different approach to how you design, and you specialize kind of in transformers, right? And obviously the whole big picture thing, but the transformer aspect.
Yeah, my early background was in transformer manufacturing, actually the first kind of professional job I had. So working with the engineers at a manufacturing facility to build and test transformers to engineering specifications. So I learned all that aspect of it. And when I started with Rupert Neve Designs, I'm in my 10th year now, one of the first things I initiated with Rupert was to have him teach us his methods for audio transformer design. So we actually held class every Friday for about 4 or 5 months.
Oh, that's awesome.
And Rupert would come in and do training and test us
right.
on those things. But that kind of brought it full circle to the mechanical aspects that I knew, the testing parameters that I knew, and now the specifics for audio from Rupert's perspective and his design criteria. So.
Right. And we were talking before the cameras were rolling, and R&D takes a little different approach. Instead of taking an off-the-shelf transformer and designing a circuit around it, you kind of work the other direction. Tell us how that process works.
Yeah, we work in that combinational circuit area where we design transformers specific for each application. So we work through circuit development, circuit subsystems, the topologies that we want to use, and then we work in specific transformer designs that match those circuits. So that's really what's kind of unique, I think, about us is our custom transformer designs and how it interacts with the circuitry.
Right, and that's kind of been Rupert's heritage through all of the years and all the amazing products that that he's made. Yeah,
and that is history with the company. That output transformers in particular, every product. That's what's required. So.
Right. So we're throwing this word transformer around, and we see it all the time in marketing materials and in product specifications and things. And I think, well, even for myself, what does a transformer really do in this circuit? I mean, why does that matter? Why do we care that there's a custom designed transformer in there?
It has a number of applications. I mean, for one thing, with our products, we do run a lot of high voltage power rails, and that helps in a couple of aspects. In the kind of first order, it improves the signal to noise ratio, reduces the noise floor. Mm-hmm. So it gives you a benefit there. But also, when you design a transformer, the transformer design that is a step down from a high voltage operating level internally, stepping down to the operating level that you need to interface with, that actually produces a better performing transformer design. As opposed to a 1-to-1 ratio or a step up, if you might be running lower internal voltages, we actually get transformer designs that perform better, have less of the kind of artifacts and undesirable effects of a transformer are minimized to negligible when you do a proper design. So mm-hmm. the circuits interact with the transformer design in particular that way. Right.
So for me as an engineer sitting in my studio, what does the transformer mean? Why is it desirable to have that transformer in the circuit?
So a number of things. The magnetic isolation and the ground-free connection mm-hmm. Eliminates any possibility of any hum or buzz or interconnect problems. Unbalancing, you have a fully balanced transformer output, you can hang one leg to ground and connect it to any unbalanced equipment and it performs perfectly. Where any kind of active balanced output, the first thing you do is you lose 6 dB as soon as you ground one leg. And typically you have increased distortion parameters because one leg is driving ground and they don't like to do that so much. Mm-hmm. So we have that really wonderful interface of a transformer. The other major aspect, and this is going back to the history of Rupert's early products, and those transformer designs were kind of rudimentary. We have more sophisticated designs that we do these days. They had inherent distortion characteristics that were just a natural part of the magnetic core saturation and the properties of a transformer. That is what produced the sound that everybody reveres of those vintage products.
Right.
Modern transformer design, we actually add in an extra winding that goes into the feedback loop of the amplifier. So we can fully cancel out all of those inherent distortions. So we can produce very low distortion outputs through a transformer. So you have all the benefits of the transformer, magnetic isolation, and you can still have a very clean output. Now what we've advanced to do is you take some of that feedback and you selectively filter out portions of the feedback, which reintroduces the harmonic distortion parameters that you want. And in fact, we've taken it even beyond going to vintage. We've learned to push it well above what the vintage products did. So we really have full control, variable control of that harmonic content.
Right.
So that's a real benefit of having a transformer output, in particular in our designs where we have the what we term the silk circuit.
Right.
And that's what that does.
Right, right, yeah. It's so effective for giving you just a variety of textures and sonic qualities that you can add to your recordings.
Yeah, you can bring in the harmonics. It is low order harmonics, and we're very particular about second and third order only. You want to rule out any of the stuff. You want that musically related harmonic. That's the enhancement that you're after. And the ratio of second to third can be varied a little bit, and that's where you really get varying textures. How much third harmonic, how much second harmonic, and what are you after for what sound character and that vintage quality.
Right, right, so cool.
Yeah.
Well, as long as you're educating us here, I have other questions.
Sure.
So we also see Class A is thrown out a lot, particularly with the higher end gear. What does Class A mean, and why do we care?
So in an amplifier design, Class A sits at the zero crossing is actually at half power, half voltage. So there's the more traditional, more modern amplifiers for efficiency are Class AB, which means that there's a positive half and a negative half in the electronic and the transistor outputs that when you're at zero are shut off. When the signal swings positive, the upper transistor turns on. When the signal swings negative, the lower transistor turns on. But that crossover region, when the top transistor is turning off and the bottom transistor is turning on, produces a type of distortion which is non-harmonically related distortion. It's very undesirable. So a good Class AB amplifier, that's really negligible. Class A has none of that because it never reaches cutoff. You're always operating in the linear range of the output stage. That type of crossover distortion is something that Rupert has just been a bulldog about. You cannot allow that in our circuits.
Right.
So again, he's very particular, and what he's taught us is about the harmonic relations, that those lower harmonics, and you must suppress everything above third harmonic. That's just so important. And that's where a Class A output stage eliminates any possibility of those upper order harmonics. Where a Class AB, again, a well-designed Class AB, they're very minimized, but they're non-existent in a Class A.
Right,
So
right.
That's really what the goal is there.
Sure. And just to clarify, when you say amplifier, we're not talking necessarily about guitar amplifiers. You're talking about preamplifiers. You're talking about all types of
Gain stages within the products, whether it's
Right.
in the front end of the mic pre, in any of the equalizer or compressor circuits that we design, how we manage the signals through those various circuit designs and stages.
Right. Those are all amplifiers, basically.
Right, that's
that are
correct.
Doing things to one extent or another. You mentioned earlier high voltage, and that's something that the R&D products are always based around, and you said that can help push the noise floor down. Are there other benefits to having high voltage inside the box?
It doesn't help with dynamic range so much, a little bit, but it's really noise floor. But again, how it interacts, how the circuits interact with the transformer design is the biggest part of it, because by varying that voltage, that enables us to manipulate the transformer design to perform the way we want the transformer to work. So we really work with that in conjunction. We work back and forth between the operating voltages and getting the right transformer to produce the output level that you need for your outside world interface to get back to nominal levels. So that's the biggest part of it, really.
Right, right, I see. So tell us a little bit about how a product goes from, I'm assuming Rupert or you or the other designers, you've got some kind of like sketching on a napkin or in a notebook or something.
No,
How does it get from there
absolutely
to a product that we hold in our hands?
Yeah, so Rupert does not work in modern CAD tools. He does do pencil sketches, whiteboard sketches, things like that. And that's the kind of things that he delivers to us. We've termed it RupCAD. And then we translate that into the proper engineering tools that we need to produce printed circuit boards to go to manufacturing. And there's many steps in that process. The first thing is to do the schematic capture. You can do analysis of that. And we always breadboard circuits. I mean, a lot of what we do in the product development is listening. We'll breadboard up circuits for little segments. For this section, here's an amplifier idea. And maybe we'll do some A-B comparison about a couple of ideas. In the end, when we get to a fairly close to complete product, now we do more extensive listening. So the A-B is really good for comparing this circuit to that circuit, and you're thinking about little specific sections. But when you come to a product, and this is something that Rupert has really pushed us on, long-term listening. We'll spend days and weeks just listening. And it's that extended listening period that you get comfortable. Are you comfortable with this product?
Right.
Does this sound right? Day after day of listening, and you really need to create that product that kind of enhances the emotional content to the music.
Mm-hmm.
That's what we're after. And you don't get that from a quick A/B test. You really just have to listen for a long time.
Right,
So,
right. That's a lot of work. How long does it take from the paper sketch to when the product is shipping?
it depends on the complexity of the product and how much we might be able to reuse from previous designs. We have a library of journals going back a long time for Rupert. He's always done this for himself and all of our engineers. Every concept, every product idea, every circuit idea, everything is documented and written down. All of the test results, the variations we've tried, what the impact was. So we have this lineage of library information that we refer to. So you can always build on what you've done before. You can always get better. You don't have to relearn that every time and figure that out each time. So we've got a lot of the historic notebooks and a lot of the, even for the past 10 years, information that we've developed, circuits that we've developed. So you take that, you build on it. As far as what it takes to go through a product development, for some of the analog products where we have history of similar circuits, but we're putting it in a new package, or we're running at higher voltage rails and are moving away from IC-based to discrete amplifiers for higher end products. They can take up to a year by the time you do all the schematic capture, PCB layout, listening, comparison, prototyping, pilot runs on products, metalwork design. Before all that comes together and then you actually get out to manufacturing, at least 8 to 10 months and up to a year to a little bit over that for a typical product.
Wow, that's quite a process.
Yeah.
Quite a process. So we talked about transformers, but I would assume that the other components inside the box there are going to be some critical components there as well.
Very much. That's become a challenge. Today's modern manufacturing of components is changing a lot. The typical parts that we've used for 40 years are becoming rare or even obsolete. Discrete transistors, there are still some very good companies that produce these products, and there's a lot of generic stuff, but some of the very high-end components that we have kind of maintained through multiple products, you start to see things go away. And now you've got to search out alternates, qualify parts, and you can spend days and weeks just qualifying individual components to make sure that these work in the circuits and the designs that we do. So that's kind of a daily challenge. You face that. You get calls from manufacturing. We can't find this part anymore, and now you've got to go scramble and start working on substitutes and alternates and things like that. So that component selection aspect is an ongoing challenge every day.
I imagine so. Yeah. So I'm curious, my last question for you. Yeah. From your perspective, working with the signal path, everything from R&D does everything from DIs to summing mixers to headphone amplifiers. Yes. If someone is looking to upgrade their studio and wants to have the biggest impact, what component along the whole signal path is in your opinion, the most important to upgrade?
Of our products, in modern recording world where everything is digitized for the most part in the recording process, and there are a lot of plugins that emulate many of the hardware products that we do. And there are certain things that emulation does very well, virtual circuitry does very well. But there are certain areas where analog will never be replaced and can never be replaced, such as a microphone preamplifier. And since that's the basis of your sound recording, is getting a good, high-quality recording to then start working with EQing, compressing, whatever you want to do. I think the microphone amplifier is really the fundamental part of the recording process. Microphone placement, the microphone that you select for the job, the preamp that you use, recording at the proper levels. Now you've got something to work with. Now you can mix and overdub and do everything, but you've got good, solid recording as the basis of your product. So
right. Awesome.
I think that's very important.
Awesome. Well, I appreciate your perspective on that and all the education you provided for us today. It's a wonderful to have you here at Sweetwater.
It was fun. It's my first time here. It was really interesting to see everybody, and the facility is tremendous.
Oh, thank you.
So I get a great look at that, and
thank you.
Really enjoyed it.
Yeah. Well, again, thanks for your time, and come back soon. We'd love to have you back.
Yeah, I enjoyed it.
All right. And thank you for joining me for the Sweetwater Minute. I'm Mitch Gallagher.